All right, so in assignment number 4, we're going to be simplifying radicals by rationalizing the denominator. And we're going to talk about what that means. And here's why we have to rationalize the denominator. Suppose we have just the square root of 5. I'm going to write that up here. Maybe I'll change colors. Suppose we have just the square root of 5 here. And if we take the square root of 5 on our calculator, we could probably round it to 2.23 or maybe 2.24 or 2.2 if we round to the nearest tenth. But then let's say we want to use that number for some reason. Solving an equation, let's say we have something like 1,000 and we divide it by the square root of 5. Well, if we take 1,000 and we divide it by the square root of 5 on our calculator, we're going to get 447.21. Now, what a lot of people will do, because they don't simplify radicals, they have to round it. And so a lot of people, instead of taking 1,000 divided by the square root of 5, would take 1,000 divided by what they round that to, which is 2.2, and they think they're going to get something close to what the actual answer is. We know the actual answer is 447.21, but if you take 1,000 divided by 2.2, you're going to get 454.545, repeating. And we know that these two things, although they're relatively close to each other, they're still they still are off by about 7 points, 7 numbers. And so for that reason, we try not to leave a radical in the denominator. Like here we have the square root of 5 in the denominator of a fraction. What we want to do is change that so we rationalize the denominator. And so here's how we will do that. If we have a over the square root of b, we can simply multiply the top and the bottom of this fraction here by the square root of b over the square root of b, because then we're going to get the square root of b squared. And since we can pull them out in groups of 2, that is just going to end up being b. Now at the top, we can't multiply in the a and the b together because one's inside and one's outside of the radical, so that just becomes a radical b. But it's okay to have a radical in the numerator, because when if you estimate a number that's in the numerator, you're not going to be as far off as if the radical was in the denominator. And so a over radical b would be much simpler written as a radical b over b, which seems silly because there's more stuff here than in our original question. But if you think about it in terms of what you're going to round to get a correct answer, you're going to be closer using the more simplified version than a over the square root of b. So let's talk about how to do this. If we have something simple like 3 over the square root of 2, we have to get rid of that square root of 2. So what I'm going to do is multiply both the top and the bottom by the square root of 2. We know we can do that because the square root of 2 over square root of 2, that's just 1. So I'm multiplying by 1, and anytime I multiply by 1, the fraction or the number doesn't change, it just stays the same. But it's going to be in a different form. When I multiply the numerators together, I'm going to have 3 times the square root of 2. But when I multiply the denominators together, it's the square root of 2 times the square root of 2, which I could say is the square root of 4. But the square root of 4 is 2. And so this, in a more simpler version, would be 3 radical 2 over 2. And you can see here the goal is to make the denominator, the bottom number, a rational number, whereas in the beginning it was irrational. See how that would look like with number 2. I'm going to start doing it the same way that we did the first, and I'm just going to multiply by the square root of 6 over the square root of 6. So in the numerator, I'm going to have 5 times the square root of 3 times the square root of 6. Well, that's 5 times the square root of 6 times 3, which is 18, over the square root of 6 times the square root of 6, and the denominator is the square root of 36, and that we know is just 6. Now, we could leave it that way, but it's possible, and it is the way in this case, that we can take the square root of 18 and simplify that. We know that the square root of 18 is the square root of 9. The square root of 9 times the square root of 2, and the square root of 9 is simply 3. So the 3 is on the outside with the 5, and we would take 5 times 3 to make it 15. We still have a square root of 2 here, and then that's all over 6. And then we can simplify those two whole numbers. 3 goes into both of them. 3 goes into 15 5 times. I can't do anything with the square root of 2. and 3 goes into the 6 twice. So this would simplify to 5 radical 2 over 2. Now there is another way to do that, and that would be to recognize that we could simplify the numbers underneath the radical signs first, just like we can simplify numbers outside of the radical signs. So if I take the radical 3 over radical 6, I can write it like this. This is 5 times the radical 1 over radical 2, because 3 over 6 is the same thing as 1 over 2. Now the square root of 1 we know is just 1, so that's 5 over the square root of 2. Now I still have to rationalize the denominator, so I would multiply the top and the bottom by the square root of 2, and I would get on the numerator 5 times the square root of 2 over the denominator, which is the square root of 2 times the square root of 2, which is the square root of 4, or just 2. And you can see I get the same answer both ways. Let's take a look at another example. Let's take a look at what happens if the denominator, underneath the radical sign, has a variable in it. We're going to do it the same way. We're just going to take the square root of x over the square root of x here. So in the numerator, I'm going to have 7 times the square root of x. But in the denominator, the square root of x times the square root of x, well, we could say that's the square root of x squared. But we take the variables out in groups of 2. So that's just going to be x. So in simplified version, the simplified version would be 7 radical x over x. Now let's take a look and see what happens if we have both variables and numbers underneath the radical sign. So what I'm going to do here is I can't simplify 11 over 2, so I'm just going to write this as the square root of 11 over the square root of 2x. But then I want to rationalize the denominator, so I'm going to multiply by the square root of 2x, both on the top and the bottom. So the numerator is going to be the square root of 11 times 2. I can multiply these together because they're both inside the radical sign. That's going to be 22x over the square root of 2x times the square root of 2x. I can think of that as the square root of 4x squared. But the square root of 4 is 2, and the square root of x squared is just x. So my simplified version is going to be radical 22x over 2x. Let's try one more here. Here we have things inside the radical sign, outside the radical sign. I've got a lot of things going on here, but this is kind of nice because if we recognize that we could simplify this first, I can write this as 5x over 2, but the radical part, the x's can cancel out, and the square root of 6 over the square root of 3 is simply the square root of 2. And so this would be my final answer. Now suppose I didn't do it that way. Suppose I really wanted to rationalize this. It's going to be a long process, but let me show you what this would look like. I'm going to rewrite it down here. We have on the outside 5x over 2. Then we have the square root of 6x and the square root of 3x. We could do this if we didn't recognize that anything's simplified. Just multiply both the top and the bottom by the square root of 3x. That's going to give us in the numerator 5x times the square root of 6 times 3 is 18. X times x is x squared. And in the denominator, we're going to have 2. But then the square root of 3x times the square root of 3x, we could say that's the square root of 9x squared. But the square root of 9x is 3. The square root of 9 is 3, and the square root of x squared is x. So if I simplify this, we would have 5x times the square root of 18x squared all over 6x. Now you can see it doesn't look at all like what we have up here yet, but that's because several things can be simplified. First of all, these x's can cancel each other out. And in the radical here, we have the radical 18, but we know that that's the same thing as the square root of 9 times the square root of 2, and the square root of 9 is 3. So I could take that 3 times the 5 and get 15. Also, I can pull out this x here because it's x squared, and so those come out in pairs. And I have this 2 that I didn't pull out that stays inside the radical sign. And that's all over 6. Well, then, just like in the last problem, the 15 over 6 can be simplified because 3 goes into both of them. 3 goes into 15 5 times, and 3 goes into 6 twice. And you can see I end up with the same thing here as I did at the beginning. So this is how we are simplifying radicals. Let's just take a look and how do you know whether something is simplified. A radical is simplified when 4 things happen. Everything that can come out of the radical is out of the radical. So if you have a perfect square or a pair of variables inside the radical, all of those things must come out. There can't be any fractions inside of a radical, so I can't have the square root of, let's say, a half. I'd have to write that as the square root of 1 over the square root of 2. I can't have a decimal inside of a radical. Okay, so I'd have to change the decimal to a fraction and then write it as the square root of the top over the square root of the bottom. And then there can't be a radical in the denominator, like there is in this example here. Once all those things are done, then you know you have a completed simplified radical. And that's what we're going to be doing on our homework. Good luck on that, and we will see you tomorrow in class.